Good morning all. This is Kalai Chelvi from Department of Computer Science and Engineering from Erode Singundar Engineering College. Today my topic of discussion is structures in C. Structure is a heterogeneous one because this structure handles different data types. For example, we want to handle a student record. A student record may contains a name of the student, roll number of the student, test marks of the student, and grades of the students. So all these things can be considered as a different data types. So name, roll number can be considered as a character array, and the marks can be considered as an integer value, and grade can be considered as a character one. So to handle all these different data types, we are having a data type which is called as structure. That structure is called as a heterogeneous one. So it is a collection of values of possibly different types. Structure terminology. A struct is a group of items, that is a variables, which may be of different types. Each item is identified by its own identifier, each of which is known as a member or field of the structure. A struct is sometimes called a record or structure. Structs are the basis of classes in C++ and Java. So before going to see what is the example of structure, we want to know the syntax of structure. So here is the syntax for structure. Struct, structure tag, and the member definitions ended by one or more structure variables. Here the struct is a keyword and struct tag is the name of the structure, and the member definitions are nothing but the data members of the structure, and that the data members can be handled by one or more structure variables. Here is an example for structure declaration. A structure is defined with a character array, two character array, and a single character variable. One first is a character array, last is a character array, and mid-int is a character. So this declaration creates two structure variables, sname and ename, each of which contains three members. So we can access the first name, last name, and mid-int by having the syntax sname.first and ename.midint. In this way, we can access all the data members of the structure. So this is the way, here is the description to how to access the data members of the structures. To access the members of a structure, we use the member access operator dot. Dot is the operator which is used to access the data members of the structure. Here is the example which assigns the value to the data members. The first one, string copy of sname.first, comma Sudeshna. This assigns the value Sudeshna to the first, and sname.midint is equal to k. So this assigns the k value to the midint, and str copy of sname.last, comma Sarkar. So this statement assigns the values, that is the string is copied, Sarkar is copied to the last name. Tagged structure. So we can define the structure in this way also. So this definition creates a structure tag name type containing three members, first, midint, and last. Variables may be declared by type struct tag name. So we can have the usage of typedef keyword, which is normally used to give the names to the struct type. So typedef is normally used to give the alternative name for an existing data type. So here actually we are having a structure named as name type with three data members, and which is having the structure variables sname and ename. And this can be handled by giving the type defining by, it can be defined by using the typedef keyword, and this struct uh, this struct can be renamed as n type. So here with the help of the typedef keyword, we are giving the another name for the structure as n type. So we can also access the uh, structure with the name n type. So because this typedef helps in defining an alternative name for the structure. So actually original name for the structure is name type. With the help of this typedef keyword, we can able to give an alternative name. That alternative name is considered as the n type, and we can use the structure variables with the name structure name n type. So here it is defined like this: n type a name comma b name. And using this typedef keyword, we can give the definition like this. So the typedef struct and the data members are the first, midint and last, and the structure name is given here, that is name type. So name type is defined with the structure variables sname and ename. Here is another example for the structure. The name of the structure is student record, which is defined with the help of the typedef keyword, which is having the data members as name, roll number, class test, mid name, final and grade. So this structure defines a new data type called student record. In this declaration, we does not have a structure variable. So here is the name of the structure, and we can't able to define a structure variable here. And the structure variables are defined here. Student, in this way we can give the structure name, structure variable. So this is declaring structure variables. So here for the previous structure student record, we are defining the variables as two variables s1 and single. So s1 is the first structure variable of the student record. Single is the second variable of the student record. Things you can and can't do. You can use equal to assign whole struct variables. You can have struct as a function return type. You cannot use double equal to directly compare structure variables, but it can compare fields directly. We can't able to compare two structure variables, but the fields of the structures can be compared. You cannot directly scanf for printf structs, can read fields one by one. Next is structure initializer. So we can initialize the value to the data members of the structure. So here is the one of the example which assigns or initializes values to the student record. So we are having we have the name of the student, roll number of the student, and marks of the student, and grade of the student. So we have declared a structure here. We have created a structure here, and for this structure we have assigned a value with the help of this statement. So this statement helps in assigning the values to a structure. So this is nothing but the structure initializer. And also another way of assigning the values to a structure is this one, using components of struct variables. So with the help of the structure variable, we can able to assign values to the data members of the structure. Or otherwise, we can also use the scanf statement to get the values of a structure. So whenever we are assigning values to the data members of the structure while doing our program, so this gives belongs to the concept of the compile time initialization. When we are assigning values to the data members of a structure with the help of a scanf statement, this belongs to the category of runtime initialization. assigning whole structures. So here already we have denoted that we are having the two structure variables S1 and single. So here we have assigned the value of the variable structure variable single to the structure variable S1. So this statement is possible and it is equivalent to this one. Str copy of S1 dot name comma single dot name. This means that single dot name, the name of the single structure variable is assigned to the name of the S1 structure variable. And similarly, we are assigning the roll number of single structure variable to the roll number of S1 structure variable. And also assigning the class test marks of single structure variable to S1 structure variable and so on. So this means that assigning each and every data member's value from one structure variable to another structure variable. So instead of going these many number of statements, we can have a single assignment like this. S1 is equal to single. This means that the data members of the single is assigned to the data members of S1 structure. So within a given structure, the member names must be unique. Within a given structure, we have to provide the data members as a different data members. The member names must be unique. However, members in different structures may have the same name. So different structures can use the same name. A member is always accessed through a structure identifier. You can access the data members of the structure with the help of structure identifier. The structure identifier is nothing but the structure variable. Consider here we are having the two structures. One structure is named with fruit, another structure is named with vegetable. But listen, here we are having the data members as name and calories. This is for fruit structure. The same data member name is used for the vegetable structure also. Here also we are using the same name as name and calories. See here, struct fruit mango. So this mango is said to be the structure variable of this fruit structure. And struct vegetable potato. So this potato is said to be the structure variable of the vegetable structure. It is clear that we can access mango.calories and potato.calories without any ambiguity. So this is possible. Even though the names are same, but it belongs to different structures, there will not be any opposite happenings when we are accessing this. So this is accessed with this structure variable mango.calories, and this is accessed with the structure variable potato. So this gives the different meaning. Complicated structures. So here we can have structure within a structure, that is a nested structure, and also a concept of array of structures. These are all said to be the complicated structure. A member of a structure can be an array or another structure. So here we are having a structure, grocery list, and within this structure we are having the data members of the structure as another structure. So this is also possible. And also we are having the array as a data member of a structure. So this concept is said to be, this example belongs to both the category. One is the array within a structure, and an array, that is a structure can be an data member of another structure. And also the next is an array of structure. So here we are having a structure called as chord. So for this chord structure we are having the data members as pips and shoe, whereas the structure variable of this structure is deck. So deck is considered as a array variable because this code structure can be accessed 52 times. So repetition of structure can be possible with the concept of array of structures. So next is an example program. So we are going to execute a structure program through the online compiler. So this is the online compiler. So here I am going to create a structure. So I am using a keyword struct and the name of the structure SAM, that is a sample is considered as a SAM structure. So inside the structure I am declaring the structure variables. So I plan to use 3 data members for the structure. One is integer data type, another one is float data type, the last one is character data type. So this is the way we have to create the structure. And I am writing a main function. From this main function, I can access the data members of the structure. So first, I have to create a structure variable. So actually, the structure variable can be created by 2 ways. One is here itself, I can create the structure variable. After the declaration of the structure declaration can be entered with this structure variable. This is one way. And another way is I can declare the structure variable within the main. So this is the way I have to declare a structure variable. Struct, name of the structure and the variable of the structure. So this is the way I have created the structure variable. So one is I can create the structure variable here itself, or otherwise I can create a structure variable within the main function. So now what I am going to do is I am getting the value for these data members and I am displaying the values of the data members. So whenever I want to access the data members of the structure from the main, I want to use the structure variable dot data members of the structure. So this is the way we have to access the data members of the structure. The syntax is structure variable dot data member. For example, S1 dot A, S1 dot B, S1 dot C. This is the way we can able to access the data members of the structure. So now I am going to get the values of the data members of the structure. So I am writing the code here. Enter the values for A, B and C. So this is just a printf statement which gives an alert message to the user for giving the input. Next is I am giving the values. I am getting the values with the help of scanf statement. So percentage D, percentage F, percentage C. And how can I access the data members? S1 dot A, comma S1 dot B. Sorry, actually I have to use ampersand S1 dot A, ampersand S1 dot B, comma ampersand S1 dot C. So with the help of this scanf statement, I can get the values of the data members of the structure. So now I am printing the values. the values of A, B and C are percentage D, comma, percentage F, comma, percentage C, comma, S1 dot A, comma, S1 dot B, comma, S1 dot C. Next, and 0. So now I'm running the program. So it's asking for the values of A, B and C. So I'm entering the values for A as 22, B as some 45.67 and C as, actually I have not entered the value for C. So I am executing this. Some 10, 45.67 and A. Actually not getting for A. Again I am executing. Will run like this. 12, 43.23 and A. Also I am not getting. 12, 14.67. I can't able to get the values of C here. Actually this has to be paused. The person has to be given. And stop running and run here. Okay, will not getting the output for C. Look after that. And here we can able to know what is the size of the structure. So we can get the size of the structure by executing the program itself. So the size of the structure can be got with the help of the operator, size of operator. So here we can print the size of each and every data members. Percentage D is the size of A, comma, size of A. Next is enter /n percentage D is the size of A, size of B, comma, size of B here, Next, printf /n %d is the size of C, comma, size of C. And these are the ways in which we can able to get the size of individual data members. And also we can able to get the size of the data member, size of the whole structure. So this is the way we can get this size of the whole structure. %d is the size of S1, comma, size of S1, size of S1 semicolon. Right, now I'm executing the program here. So here when we are using the size of operator, we can go with this instead of %d, can go with the control string as %ld. Otherwise it will show some warning message. Size of A Oh, okay. In what way we have to access this? This is s1.a. We have to give like this, right? Can able to access the data members of the structure with only the structure variable. So we have to use like this. s1.c. Okay. I'm executing this. Look. So this is the output. So normally the size of integer data type is 2 bytes. Depending upon the compilers, it may have the 4 as a size of the integer data type. Float is 4 bytes and character size is 1 bytes. And look here, when we are adding these values, 4 plus 4 8, 8 plus 1 9. So this may be the total size of the structure, but we are getting the total size of the structure as 12. So the reason because is this one. The size of a structure is not always equal to sum of the size of its members. Compilers may add padding between members to ensure that they are aligned properly in memory. Alignment requires can vary depending on the CPU architecture and compiler options. The amount of padding between members can affect the structure size. So because of these reasons only, we are having the different size of individual data members of the structure and the whole size of the structure. So remember that the size of the structure is not always equal to the sum of the sizes of its data members. So next is union. Union is also like a structure, except the members of union share the same space in memory. So here in structure, each and every data member is allocated with individual memory space, whereas in union, the data members of the structure is allocated with a single memory space. A same memory space is used for all the data members. The memory space is allocated with respect to the data member which is having the maximum memory size. So it is the programmer's responsibility to know which representation is currently stored in a union variable. So depending upon the size of the maximum size of the data member, the size will be memory space will be allocated for union. So this is one of the major concept we have to understand, and this is the major difference between the structure and union. So union is allocated with a single memory space. All the union data members are sharing the same space, whereas in structure each and every data member is having its own memory space. Thank you. So now we are going to run the program through the online compiler. So here I am creating a structure struct SAM. The name of the structure is SAM. So I am using the data member of the structure as integer, data member named as A, which is of integer data type, and another data member which is named as B, which belongs to float data type, and this structure is ended with semicolon. And I am writing a main function here. So I am creating a structure variable struct SAM S1. So actually this structure variable S1 can be created in two ways. One is by creating the structure variable here itself, S1. After the declaration of the structure, we can create a structure variable. This way of creation of structure variable is possible. And also another way of creating the structure variable is like this. So now I am accessing, I want to get the values for the data members A and B, and I want to print the values of the data members A and B. So for this I am writing the code here. Enter the values of A and B. So this is an alert message, gives an alert message to the user to enter the values. So now I am getting the input with the help of the scanf statement, percentage D, percentage F, comma, ampersand S1 dot A. So how can I access the data members of the structure? So as already we have discussed, with the help of the structure variable and the dot operator. Dot operator is said to be the member access operator. Dot operator is said to be the member access operator. So with this dot operator, we can able to access the data members of the structure with the help of the structure variable, right? And comma ampersand S1 dot B. That's it. We have got the values and we want to print the values what we have got through the input statement, that is this kind of statement. So /n, the values of A and B are percentage D and percentage F, comma S1 dot A, comma S1 dot B, right? So this should be ended with semicolon. Next, return 0. Okay. Now I am running this program. Yeah. So I am getting the values for A and B. A value is of integer data type. Some value 12 is, I am providing the value 12 for the data member A, and the next data member B, I am giving the value for the data member B as some 34.23. I have given the values. Next, I am printing the value here, right? So this is the way, this is a simple example which shows how can we create a structure and how can we access the data members of the structure. So here is the way I have created a structure, and this is the way I can able to access the data members of the structure. S1 dot A, S1 dot B, right? So here we can also have another structure variable S1 comma S2 also, right? So this is also possible. So in this we can able to get the values of A and B twice with the help of the structure variable S1 and S2. Okay, so this is one way of accessing the data. And if I want to get the values for A and B with the help of structure variable S2, I have to go with the option of S2 dot A, S2 dot B. In this way, I have to access. Okay, and so this is the way we can able to get the values of the data members of the structure. So this type of initialization is runtime initialization. This is actually comes with the concept of initializing the structure variables, sorry, structure data members with runtime initialization. Okay, so with the same code we can access, we can give the values of the data members through compile time also. So here I'm writing the code like this. Instead of using this printf, scanf statement, I'm assigning the value here itself. S1 is equal to A value is some 17, comma B value is some 76.54. So I have assigned the values of the data members of the structure. These two statements I don't want. So now I'm printing the values. See? So by assigning the values directly, that is by compile time initialization, I can print the values of the values of the data members of the structure, right? And here another concept is I can create another structure variable S2, SAMP S2, and I can assign the values of S1 structure variable to S2. So that is possible by giving the statement S2 equal to S1, assigning, copying values. So S1 values are assigned to S2. Okay. So here instead of printing S1 dot A, I am using as S2 dot A and S2 dot B. See, actually I have assigned the values of the data members of the structure for S1. For S1 structure only I have assigned the values. But I have copied the values of S1 to S2 so that I can able to get the that is I can access the values of S1 to S2 by this assignment statement. Here the values of A and B is copied from S1 structure to S2 structure with this assignment statement. So it is possible. Thank you.